So today we're going to talk about translating and reflecting absolute value functions. We didn't really talk about reflecting in the warm-ups, but it will come up pretty organically in these notes. But first we'll have to know what an absolute value graph looks like. Anybody needing more time on their objective? Okay. So let's first talk about an absolute value graph. What you need to know is that it is shaped like a V. Absolute value graph is shaped like a V, capital V. Or it could look like an upside down V. The parent function of y equals the absolute value of x has a vertex at the origin and a slope, we call it, of 1. The parent function is a mirror image of itself over the y-axis. So if you want to put that, it's going to be a mirror image over the y-axis. So let's go ahead and graph that parent function so we have a general idea of what these look like. And then in the next slides, we'll start changing it. So for these, our vertex is always going to be where we start. If our vertex is at the origin, where does that point go? What coordinates? 0, 0. So we put a point at 0, 0 for the parent function. This is the point that's going to be getting moved when we do our translations. Okay, then we have a slope of 1. So normally if I were to tell you you have a slope of 1, how would you write it as a fraction? 1 over 1. So from this point, where do you think we need to go? Up 1 and right 1. And we can do that a few times to get several points for that part of our V. To get the rest of our V, we need it to be a mirror image over the y-axis. Which one's my y-axis? The one that goes up and down. So we need to take a mirror image of these points on the other side of the y-axis to get our V. This is similar to when we reflected yesterday. So for example, my point at the origin doesn't get another point. It just stays put. How far away is my next point from the y-axis? 1 away, so we're going to go 1 on the other side. Next point is 2 away. And then we can see that we keep going kind of with the same type of slope except on the other side. Okay, and we can keep doing that to get more and more points. Then all that's left is for us to fill in our V, put the lines in that make it. And then put our arrows on the ends, and we have graphed our parent absolute value function. It's important that when you graph these today, all the ones we graphed today, they need to look like V's. Meaning you should not be crossing down and turning it into some sort of X. They should always look like V's. Or upside down V's. Then let's talk about how we can change them. We shift them by moving the vertex and or changing the slope. So what you need to know is this general formula here. And what A, H, and K represent. So A, or the number in front of the absolute value bars, is going to be your slope. On the parent function, when we wrote that, y equals Absolute value of x. There's not a number written in front of there, so that's how we knew that a, or our slope in this case, was a 1. H comma k is the vertex. Now this is where what we learned yesterday comes in handy. What's happening inside of the bars is kind of like what happened inside of our parentheses. Okay? Where a negative number shifted it right. So we just use a positive h here. Or a positive number actually made it go to the left side. Okay, you can think about it as subtracting a negative is how this ends up turning positive. Same kind of thing with k. K is outside the bars. Yesterday we worked outside the parentheses. And a positive shifted it up, a negative shifted it down. So our vertex is going to move the same way that our graphs moved yesterday. If we go back to our parent function, we don't have anything inside or outside of the bars. That's why we knew our vertex was at 0, 0 for the parent function. So when we go on and we start identifying the vertex, it's going to be important to remember that the x coordinate of the vertex is the opposite of the sign that's written there. So they wrote a minus h, but they used a positive h here. However, the k, the y coordinate of the vertex, uses its same sign. All right, on these first examples, all we're doing is identifying our slope and our vertex. Now, if you accidentally write m for slope, that's fine. These notes used an a for slope. So I'll use an A if you accidentally put an M because that's what we've called it before. That's no big deal. But we need to identify our slope, which will be our number, and our vertex, which will be an ordered pair on each one of these. So looking at letter A, what do you think our slope is, James? 4. The number in front of the bars is what we use as our slope. What about our vertex? So let's be careful. The x coordinate, we use the opposite of what we see. So it would be a positive 3. The y coordinate, we use the sign we see. So it would be a 2. Okay, opposite of the sign we see, same sign. And that's all that they asked us to do. Just find the slope and the vertex. What about my slope on letter B? 1/2. The number in front of the bars. What about the vertex? So for the x, we use the opposite of the sign we see. Good, -1 and -9. Opposite of the sign we see, same sign that we see. Questions on A and B on this slide? Okay. What about our slope on letter C? Good, -4/5. What about our vertex? Good, -2/7. Good. Change the sign for the x, keep the sign for the y. Question?
I have a question about how you get the vertex. Like, how do you, it's a 1, but how you get negative?
So on the slide before, it showed us that the general formula included, it was equal to a parentheses x minus h, not parentheses, absolute value bar, and then plus a k. So we have to take the opposite of that sign.
So wouldn't you have to take the opposite of -9 too?
No, because here they kept it a plus k. So that's where this gets a little tricky. We have to remember to change the sign for the x, but keep the same sign for the y. Good question. Other questions? Okay, in my opinion, letter D is the trickiest one on this slide. For letter D, what is your slope? What is it, Lydia? -1, or you could put it as -1/1. And then we have to identify our vertex.
3, 0.
Very good. 3, 0. We take the opposite of that sign by the x to get our x coordinate. So that would be a +3. If there was nothing added onto the end, it's a 0. Questions about letter D? Okay, similar to letter D, I'm going to make one more example just off to the side here. If we were to do y equals absolute value of x minus 2, what's my slope on this one?
0 over 1, 2. No, I'm in the wrong one.
So you're getting to the vertex. So our slope is what? +1. There's a 1 in front of here. If there were to be a 0 in front of there, none of this would be here, or at least the absolute value bars wouldn't. It's kind of like if you have an x, you would call this 1x, not 0x, right? So same thing here. There's a 1 that does exist there even when we don't write it. So our slope would be a 1, and again, what's our vertex? 0 what? 0, -2. So whatever's by the x changes its sign, except 0 doesn't have a sign to change, right? There's nothing there. We keep the sign of what goes in the y spot.
Okay.
So whatever's outside keeps its sign. Questions? Annabelle? Sure, I can pause for a moment. So we are going to start graphing. First, we are asked to identify the slope and the vertex. Then we will use that to graph. So what is my slope? Our slope is 1, or you could write it as 1 over 1. Our vertex is going to be where? +2, 1. Okay, change the sign on the x, keep the sign on the y.
So it would be really to graph it.
Mm-hmm.
Would you go start with 1 and then go up 2 and then right 1?
So we want to start from our vertex.
Oh, so 2.
So where is this point going to be?
Right 2 up 1.
Okay. So our vertex, we go to the right 2 and then up 1 to just graph that point. Just like you were to graph any other point, we graph our vertex. That's our starting point.
Would you go up 1 over 1?
Over
Up
which
one,
way?
Right.
Okay. Our slope tells us to start our V, we're going to go up 1 and to the right 1. And we should do that a few times to start our V. Now, to get the rest of our V, before, on the very first parent graph, we reflected it over the y-axis. That's not going to work here because our vertex needs to stay put. So in order to get our V, what directions do you think I want to go now from my vertex? If I go left 2 and up 1, that's going to make my V not symmetric. Left 1 up 1 is going to make my vertex symmetric. Okay, so that's kind of the tricky part. We use our slope to get the first half of our V, but then we have to change part of our slope to see the other part of the V.
Wait, what is that again? What was the other side?
The other side, we went left 1 up 1.
Okay.
to get the other side of our V.
So does it have to be a straight V? I mean, does it have to be a V? Form a V?
Yep, it has to form a V. A perfectly symmetric V. So what I mean by that is we don't want one side of our V to kind of go off like this and the other side to shoot up like that. It's going to be a nicely symmetrical V.
Okay.
Other questions about this first one? Okay, let's try another one. Give you a moment to write it down first. Okay, what is my slope on this one? 1 over 4. What about my vertex? Very good, negative 2 comma 3. We start our graph at the vertex. So where do I go to get to my vertex? Left 2, up 3. So there's my vertex. That's the point that I'm starting from. From there, where should I go? Up 1, right 4. We still use our slope like a rise over run. So to start my V, I'm going up 1, right 4. Up 1, right 4. Okay, and I can do that a few times. My V this time, it's really wide is what it is. So it's just a really wide open V. Almost like if you were to sketch a bird, right? Some people sketch birds that kind of look like little V's. So let's graph it and see if it looks right. So we go back to our vertex. If you want to mark it with a V for vertex so you know that's where you started from, that's not a bad idea. So from our vertex, where do we think we should go?
Up 1, left 4.
Okay, up 1, left 4. 1, 2, 3, 4. Up 1, 1, 2, 3, 4. Okay, and this is looking good. We can't get that last point on this graph, but if we put in our lines starting from our vertex going out, this V is looking good. Okay, if you want to see the symmetry of it, you could drop a line through your vertex, and it should look symmetric about that line. So here we can see it does look like it matches up on both sides of that line. Questions on example 3? We ready to try another one? Okay. Couple things are different about this problem from the last ones we've done. What's my slope this time? Negative 1 over 1. So this time I have a negative slope. Where's my vertex?
0, -4.
Very good. 0, comma, negative 4. So we graph our vertex. Where do we find it? Down 4. So the 0 in the first position means I don't go left or right. The negative 4 means I go down 4. 1, 2, 3, 4. Okay, that's my vertex. I'll put a little V by it so I remember that's where that is. So we want to treat this as rise over run.
Down 1, right 1.
Okay. Now, what's tricky about this is that if it's negative, you have to give the negative to the top number. It's not even an option on these. So before, we had a choice of where we could put it. That doesn't work this time because we don't want our line to go both ways through the vertex. So we're going to go down 1 for the rise and then right 1 for the run. Down 1, right 1. We can do that a couple times. To get the other part of our V, where do you think we need to go from our vertex?
Left.
So we still use the same rise, which means we go
Left, up, right, 1.
same
Left 1, up 1.
same rise. Where did we go?
Up 1.
We didn't go up.
Left.
We went down. The same rise means we're going down and then to the left.
What they do? Oh.
Okay. The V's are not going to be turned on their sides. They're either going to face up or face down. They're not facing sideways. If you get a sideways V, you better fix it because something's wrong.
Okay, but I got a question. So,
Yep.
never mind.
Okay. Yes, sir.
Aren't we then isn't there supposed to be another dot right there? Or
Yep, we could put one more there.
and aren't we is it like this?
Yep, and we can put the arrows down there. It keeps going on and on. That's just as far down as my graph goes. So if your graph goes down further, you could put more points on there. Yes, ma'am.
Didn't you say that we could do? Didn't you say that we can do like all the points instead of just 2 points? Okay, like I know 2 points define a graph.
2 points to find a
I
line.
mean a line.
Yep.
But did you say we have to only put 2, or could we?
I said the more points, the better.
Exactly.
Okay, so I put as many points as I could possibly put on this graph.
That sub said only 2.
Well, you need at least 2. I like the more the merrier, but it's true that you only need to have 2 for a line. Okay. Now for these V's, I would recommend more points. Of course, we would need more than just 2 because we're not doing just a straight line anymore. Good question. Other questions? Do we feel like we could try 1 or 2 of these on our own? Okay. So I'm going to put this one up and then pause our video so that you can try it on your own. So what did we write as our slope for this one?
3/2.
Okay, positive 3 over 2. What about our vertex? Good. 2, -5. So we start by plotting our vertex. Where does it go? Right, 2 down 5. 2, 3, 4, 5. Okay, and then we use our slope to start one side of our V. So where do I go?
Up 3, right 2.
Up 3, right 2. And I can do that a couple times to start that V.
Left 2.
Good. We want it to face right side up. So we know our other points need to be over off to the left somewhere, but we're still going up. So my vertex was this point down here. We're going up 3 and then to the left 2. Up 3 to the left 2. Okay. Questions about getting any of those points? Last step is to put our V lines through those. And we've got our graph. Questions, concerns? Okay. Need more time on this slide? Okay. One more I'm going to give you a minute to try on your own. But first thing, is this going to be a normal V or upside down V? Good. This will be an upside down one because our slope will be negative. So go ahead and try this one and we'll talk about it together in a minute. All right, what did we write as our slope? Slope is -1
What would it be right here?
over 1 if you want to put it over a 1. What about our vertex?
3, 0.
Good. 3, 0. How do I get to that point?
Right 3.
Right 3 and then
Stop.
stop. Right 3 is the point 3, 0. That is my vertex.
Down 1, right. Down 1.
Okay. To get more points, we can go down 1, right 1 for that negative slope.
Down 1 left.
Okay, then we would go down 1, left 1 to get the other side of our V. Draw in our lines, add our arrows, and we've got it done. Questions, concerns? Warm, fuzzy feelings?
Where did you get that term from, by the way?
I don't know. I've been saying it for a few years now. Can't remember where it started. Okay.